Good morning, all of you. My screen is visible. Hello. Hello. Anybody is there?
Yes, sir. Yes, sir.
Okay. See, today, forced commutation techniques. This is the last topic of this unit. Then we'll move on to the first unit. Forced commutation means, first of all, what is the commutation? Commutation is the process of turn off the device. So, forced means what? Forcibly you have to turn off the device. Whenever current passes through the device, bring to the zero level, then automatically the device is going to turn off. But when the input is DC supply, current will
Sir,
never
there is a lot of disturbance in your voice, sir.
Oh. Now it is okay, ma?
Yes, sir.
Yeah. The DC supply is given to the circuit. Current will never go to the natural zero. So that's the reason we have to use some commutating elements L and C to turn off the device forcibly. Means current pass through the device bring to the below the holding current or let it be as a zero. So that is the forced commutation. We have different techniques. We will discuss one by one. And that's what theory part. Forward current flows through the SCR must be reduced to the zero forcibly by an external circuit. That is going to be turn off. So that means turn off the SCR when the current pass through the device bring to the zero level. This type of turn off process is known as a forced commutation. And separate commutation circuit is required in this. The reason is in case of natural commutation, we don't require any separate circuit because naturally device is going to be turn off. But whereas in the case of DC supply is connected to the circuit, then automatically we need to turn off the device forcibly. In that case, separate commutating circuit is required. Forced commutation thyristor need to more control components. What are that? Preferably, you can see that there is a commutating elements L and C. Consequently, control circuit cost will be more. So, because we need to use additional commutating elements like L and C, that is a additional cost. This type of commutation is used in a DC to DC converters and inverters. I already mentioned that whenever input is AC, we don't require any additional circuit because here input is a DC. For that case only we need to use as a forced commutation. So obviously there is a two controllers required forced commutation. One is a DC to DC, that is a chopper. Another one is a inverter, because inverter it will convert DC to AC. And also one more step of cycloconverter. Their input is AC only, but we need to turn off the device before reaching to the natural zero. That's why we required as a forced commutation there. That is a different aspect. Now you can see the forced commutation techniques. Different commutation techniques are there based on the arrangement of the commutating circuit and how the current is going to be natural zero by using the commutating elements. All these things we'll discuss. Now we can see that there is a different types of commutation circuits. One is a class A or a type A. Some books they represented type, some books they represented class. Anything is same. And another name class A is a resonant commutation or a self commutation or a load commutation or current commutation. All the things are same. This is a class A commutation. Another one, class B commutation, are also called as a resonant pulse commutation and self commutated by LC circuit. We are using as a L and C components there So by make use of or else a tank, or you can say that across the device, so that is a class B or type B. And third one is a class C or complementary commutation. What is the meaning of complementary commutation? So there is a two thyristors are there. To turn off first thyristor, we make use of second thyristor. Now second thyristor is operation, and to turn off second thyristor, we make use of a first thyristor. So that process we call it as a complementary commutation. So two devices are there, one by one. Whenever you want to turn off first one, second one has to fire, and second one you want to turn off, first one has to fire, like that, complementary. And another one is a class D commutation, or also called as a auxiliary commutation or impulse commutation. Here the thing is, auxiliary components are used, or you can say that auxiliary thyristor also used to turn off the main thyristor. Actually, in a circuit, one thyristor is there, that particular commutation of that particular thyristor. To turn off that thyristor, we make use of the some other components in addition to the commutating elements L and C. For auxiliary thyristors, or I mean another thyristor also used to turn off the main thyristor. That's why we call it as a auxiliary commutation. And another name for this is a impulse commutation, because voltage, because of the capacitor voltage, we are going to turn off the main thyristor. That is the reason we call it as a impulse or spike voltage, a reverse voltage applied across the device that makes turn off the component or main thyristor. That's why we call it as a auxiliary commutation or impulse commutation or class D commutation. Last one is a class E commutation, or also called as a external pulse commutation. This is a separate circuit is required. You are using as a pulse transformer. Whenever you want to turn off the main thyristor, you generate as a firing pulse in that pulse transformer that will induce the voltage in the main thyristor side in the opposite direction. Automatically main thyristor is going to be turn off. So these are the type or different methods of a commutating circuits, or 5 methods. And another one, class F commutation also there, that we already discussed in the previous class. That name we call it as a natural commutation, not a forced commutation. That's why we need to discuss only these forced commutation techniques. If for some cases they may ask you to explain natural commutation, then you can use one of phase control rectifier, like a simple circuit, half wave rectifier. You can use it and represent the firing pulses, and it is going to be turn off. So next we'll see one by one, all simple logics only, and I will show you the current directions also. Try to understand, and waveforms also required in a exam point of view. You can see that class A are a resonance, or a self commutation, or a load commutation, or a current commutation. Here our intention is to turn off this thyristor. This is our main circuit thyristor, to turn off this thyristor. All the cases, don't forget to put input is a DC supply, because in the third unit onwards, all the input will be as a AC supply, because third unit is a phase control rectifier. It will convert what you call it as AC to DC. That's why in general we use as a AC, but the problem or common mistakes we are doing in the exam, the circuit is correct, waveform may be correct, but in general case input they may show as a AC supply. So entire logic will wrong. That's why they don't put any marks. So input is a DC only we required as a forced commutation. Make sure that input will be the DC. Now here is a based on the load resistance, you can see the connections also. If load resistance is large, then you can see that resistor is in parallel with the capacitor. So this is the arrangement, we can see that. And if load resistance is small, then you can connect directly in series with the capacitor and inductor. Only thing is these three components we have to select such a way that it is in the underdamped in nature. That is the main criteria in this. While we are selecting the components RLC such a way that it is in the underdamped in nature, R is less than or equal to root of 4L by C. So you have to select that components in the underdamped in nature. So that is the one thing. Now we can see that if you select the components in the underdamped in nature, automatically once the supply is given and thyristor is conducting, what will happen? The current will be gradually rises to the maximum and then decreases to the zero. So the instant current is reaches to the zero at point K, this will be happen naturally because of this component selection. If you select the components in the underdamped in nature, R is equal to root L by root of 4L by C, then automatically the nature current pass through this circuit will be gradually rises and then decreases to the zero. The instant at which the current is going to be zero, there the thyristor is going to be open. That is only the commutation. So similarly, we can see that this is the formula we have to use to select the components. And as I said, no, the value of load resistor is small, then you can connect in the series fashion. In that case also, the dampings will be minimum. We can see that the current again it is rises to the maximum, then decreases to the zero. At that instant, device is going to be open. So now we can want to derive that expression current pass through that device. All these things I of t you can define, and what is the voltage across the resistance and what is the voltage across the inductance and capacitance. All these things we can derive if it is required based on the marks given in the exam. Now we can see that commutating component L and C are used, just same whatever I explained. L and C are used in order to turn off the SCR. Another one is load resistor is very small, then the inductor and capacitor all are connected in series. If load resistance is high, then what you have to use across the capacitor, you have to connect as a resistance value. The value of L and C selected such a way that it is in the underdamped in nature, that value is R is root of 4L by C nature. So when the circuit is energized by DC, that means supply is given to the circuit, then what will happen? Current I will be first rises to the maximum and then decreases to the zero level. The instant when it reaches to the zero, at that instant thyristor is going to be turn off. So that is the reason. Now what will happen? The same current, whatever thyristor current only passes through the load. That's why this is also called as a load commutation. Why we call it as self commutation? So automatically the instant K will reaches, at that instant thyristor is going to be natural zero. And the circuit is RLC circuit. That's why in the resonance in nature, that's why we call it as a resonance commutation. So all these are the different names. And you can see this when the supply is given to that, the thyristor current will be gradually rises to the maximum and then decreases to the zero. The instant it is reaches to the zero, there is a turn off is going to be takes place. While it is turn off, I explained in the dynamic characteristics of SCR. I mentioned you that there is a reverse recovery time and gate recovery time. Then the charge particles is going to be removed from the inner as well as the outer junctions. Then the negative voltage will be developed and then gradually it will build up. Once it reaches to the source, that means that the device is completely turn off. So this is the case of when the large resistor is connected. That's what DC voltage is applied. Then gate pulse also we have to given to turn on the SCR. All these 5 methods, what is our intention is turn on the main thyristor and apply some mechanism, turn off the main thyristor. That is only the thing. Now after certain time, charging current decay to the value is less than the holding current, and then capacitor is charges to the supply voltage, and that's what I mentioned at point K. the device becomes to the 0, the commutation is going to be takes place. Time taken to turn off the thyristor depends upon the resonance frequency, and the resonance frequency is a function of commutating components. So that's what at what instant the K point is decided. While you are selecting the components, based on that you can choose that. So preferably we'll use this higher frequencies up to 1 kilohertz of frequency operation. You can make use of this commutation. In general, all series inverters we can use the this type of commutation. So what is the series inverter? I mentioned in the previous introduction, inverter type. There is a bridge inverter, series inverter, and parallel inverter. In that nature, commutating elements are connected in series with the device that we call it as a series inverter. Now anyhow, we use these commutating elements in series with the load, then we can see that that is a series inverter. Now our commutation circuit also like that. That is the reason this will be used under series inverter. Now if you want to design commutating elements or current pass through that, all the normal network problem, you can see that supply is given, then input is VDC and RI plus LDI by dt plus 1 by C into IDT. So that is a current pass through that device we have to find. For that reason, voltage equation we made it. From this, what is I? Just differentiate both sides by L, because we make it as a di by dt notation, and then differentiate once again, we'll get it as a differential equation d square I by dt square plus r by L into di by dt plus I by LC, that is equal to 1 by L into di by dt. So now what we have to do, the homogeneous equation, and then second order is given below, just that is equal to 0. From that I of t we can represent it in the underdamped in the case. So just this is a differential equation. I can get I is equal to, from this, so e power minus epsilon t into a1 cos omega t plus a2 sin omega t. A1 a2 are the constant we have to find by substituting the initial conditions. So for that where epsilon is r by 2l and then omega naught is 1 by root LC, and omega I can represent omega naught into root of 1 by 1 minus del square. So now what we want to find is at initial condition the current is equal to 0, and you can get what is the A1 value and A2 value. These A1, A2 value you can put it in the I of t expression, then you will get this expression. This is a I of t. Now what you want is different instants across the device. You want to find anything. This equation shows that thyristor I goes to be the 0 at omega t is equal to pi. Omega t is equal to pi. If you represent, that will be the current pass through the device. The thyristor current goes to the 0, and t you can find this. That's what I mentioned, at what instant that is going to be as a 0, that decided by commutating element parameters. If you change this parameter, automatically thyristor value at the t instant is going to be changed. Now just to differentiate di by dt for this equation, and you can simplify further, we'll get what is the voltage across the capacitor Vc. Voltage across the capacitor Vc, because all are in series, no? So you can see this voltage across the capacitor. If you want to know, the sum is equal to all these things, no? So Vc is equal to what I can write, input VDC minus VL. So this is a voltage across the inductor. So if you do that process further, we know what is the inductor voltage, that is LDI by dt. Already you know di by dt, because I of t is known. After that, if you differentiate with respect to time, we will get di by dt. So we know what is the VL, and EDC is known. Subtract that, you will get it as a what is the voltage across the capacitor. All these mathematical relations. So we get Vc is equal to VDC into 1 plus e power minus pi r by 2 omega L. And now if omega naught is a initial state of voltage of the capacitor, then you can represent minus omega naught also, you can incorporate in that fashion, and you can further simplify this equation, and omega is greater than 0. Now calculate the condition for underdamped in nature. So now this is the relation we can able to get, or from this r is equal to root of 4L by C. Similarly, you want to derive for or in capacitor in parallel with the load resistor, then the voltage equation will modify and simply you can simplify that equation, you'll get it. Now we'll go for as a class B commutation, or also called as a resonance pulse commutation, or self commutated by the LC circuit. Now we can see this circuit is still small modification. There is a supply VDC and then thyristor T. This is our main thyristor. You need to turn on first, then we'll see the waveforms. After that, how this thyristor is going to be turned off. So first we need to turn on, and then all the process of all the methods, what we want to do is you turn on the first, which one you want to commutate. After that, use the commutating elements you have to turn off. So now we can see that load resistor is RL, and make use of this, the resonant pulse or by LC circuit, you have to turn off the main thyristor. So now we can see the waveforms. It is very simple. What I want to do is first supply is given to the circuit. If I given supply to this circuit, what will happen? Anybody just analyze the step by step. It is very self-explanatory. One supply is given to that. Let assume that thyristor, I am asking before this instant. So that T is equal to 0 instant. Before this point, just I am giving supply to the circuit. Then what will happen? What will happen? Anybody? Supply is given to this, then what? See that current will pass through this. See the direction. Current is passing VDC. It won't go to the thyristor because it is in the up state. I am asking the instant supply is given to the circuit, and it goes to the inductor, then capacitor, and then it goes to the resistor. After that goes to the VDC minus. So then during that instant, thyristor is going to be off state and capacitor is charged with this polarity. That is the mode 0 operation, or you can say that simply before starting the actual operation, capacitor is charged with how much? VDC, because whatever input is there, that is directly connected through inductor and resistor, the capacitor is charged, so that magnitude is a VDC. Now what next? I switched on the thyristor. Let's start with mode 1 operation. I turn on the thyristor by giving firing pulse to that. So now thyristor is turned on. Then what will happen? Anybody? Try to understand the step by step. First mode of operation, supply is given, or 0 mode, you can say that. Once the supply is given to the circuit, capacitor is charged. So the path will be VDC plus L, then C plus C minus, then RL to this VDC minus. So capacitor is charged. After that, now whenever you want to turn on the thyristor, you just give the firing pulse to the thyristor. Once the thyristor is turned on, what will happen? Circuit operation. See that. Once if you understand this operation, you can easily draw the waveform. See that we started the operation, I giving firing pulse. Once pulse is given, what will happen? Current is passing like this. Now you can see current is passing through VDC, goes to the T, then R, and then goes to the source. So one current, this I call it as a load current. Now current is passed through the thyristor. Then is there any other current? Because capacitor is already charged, now we made short to the device, means we are fire the device. Now another current also there to pass through like this. What is that current? Commutating current or a capacitor current. There is a two currents pass through this. So one is a load current directly in this path. second current C plus, you can see the direction, C plus, it goes to the L, then T, anode to cathode, then again C minus. Then what will happen, you can see that there is a two currents, one current is like this, other current also passes through the thyristor, then sum of these two current passes through the SCR. That's why we can see that load current is remains constant because load is fixed here, and this will be the constant magnitude, and then while it is discharging through the capacitor and reaches to the 0 and then reaches the maximum, and then it is in the decreasing in nature. Why it is decreasing? Because once it is discharged means that capacitor is charged in the reverse polarities. Now this upper plate, once the capacitor is completely discharged, then capacitor polarities will reverse. Upper plate is minus, lower plate is plus. Then what will happen? What is the meaning of that? Upper plate is minus and lower plate is plus. Then you can see that current is now passing through this direction. This is a current direction. Now it shows that what is the thyristor current now? Earlier thyristor current, let it be IT, that is equal to, one is a load current, another one is a plus IC current or a commutating current. After some instant, the capacitor is completely discharged and polarities will reverse. Then what is the thyristor current? What will happen now? IL is fixed one, means load current, and minus IC. Why? Because this current is passing opposite to the main thyristor. Therefore, the resultant current must be 0. Then only thyristor is going to be turned off. When the resultant current will be 0, if the capacitor current is gradually increases, once the capacitor current is equal to the load current, then the resultant current will be 0. That's why this current is gradually decreasing. Then finally this current will be decreasing the load current. Once this point reaches, automatically means this capacitor current is more than the load current, the resultant current will be 0 and thyristor is going to be turned off. Once thyristor is turned off, then voltage across the thyristor same as the source. That's why there is a negative will be present while it is turned off, and then it become as a positive, means voltage across the thyristor same as the source voltage. Again cycle will be, once this is also open because it is turned off, then what will happen? It will be same as the 0 position. Now capacitor is going to be charged with this polarities. Now it will become upper plate is plus, lower plate is minus. After that, whenever the instant you want to turn off, turn on the thyristor, again you can give the firing pulse. That means cycle is going to be repeated. So what is our explanation is, so very simple explanation. Initially supply is given to the circuit. This will going to be, capacitor is going to be charged through source, inductor and load resistor, and after that at t is equal to 0 instant, fire the thyristor T. Then the two current will pass through this. One is a load current, another one is a capacitor current. And after that, if the capacitor is completely discharged, that charge in the reverse direction, then the polarities will reverse. Once the polarities is reversed, capacitor current flows opposite direction to the main thyristor. Then when the capacitor current is increases beyond the load current, then automatically net current passed through that will be 0, and therefore we can get it as a thyristor current will be 0. And now SCR, can see this, SCR voltage will be negative while it is turn off, and once it is completely turn off, it will become as a source. So that is the procedure. Same thing I have given some slides for animation also prepared like this. We can see that initially what will happen, supply is given. Now the current is passes through the inductor, capacitor and RL to load. So that means what will happen? Capacitor will be charged. So after that, what I had to do? I give the firing pulse to the thyristor T. Then you can see that one current is a load current passing through the source T RL, that is a fixed constant magnitude, and other current, because already capacitor is charged, so then what will happen? You can see that this current is passing through the loop, that is a LC circuit. Now after some time the capacitor is discharged completely and polarities will reverse. So now we can see that what will happen? Polarities are reversed, lower plate is plus, upper plate is minus. Then you can see this yellow ball is passing opposite direction of the load current. So both are in opposite direction. Now you can see that it is opposite. The resultant current will be gradually decreases. Once this current, capacitor current, is more than the load current, then automatically thyristor T is going to be turn off. Once thyristor is turn off, what next? As usual, the current is passing through the inductor, capacitor, and then this is same as the zero mode of operation. Now again you want to fire the device, you can fire it, because the polarities are upper plus and lower minus. It is a forward bias, and you can able to give the pulse to the next cycle. So that way cycle is going to be repeated. Same thing I mentioned in the theory part for your material purpose. Two currents will be there. One is a load current, another one is the commutating current, and after that what will happen? Commutating current is opposite direction, and all the things I mentioned. Capacitor C becomes completely discharged, means starts getting charged in the reverse polarity. So once it is a reverse polarity, it is opposite to that of a load current. And once it is opposite current, if that current is greater than the load current, what will happen? It becomes turn off. So all these things only for your reference. But if you are able to understand the circuit and waveform, you can easily write this part. So now, when what will happen? Thyristor is turned off, capacitor get again charged to the original position, and once it is fully charged and thyristor is ready to conduct, you can charge that. So now, from this, what is observation? So it is getting on for some time and off for some time. So this is a, we can say that used in the on and off for something. So that is the depends upon our requirement. We can able to on and off. Desired frequency is on and off. Designing the computing components as per our requirement. What are the computing components here? L and C. So that we have to find. So main application of this process is a DC chopper. So whereas in class A used in a series inverter, and this will be used under DC chopper. The advantage of longer oscillation period, because on duration as well as the off duration both there, that is the reason we can see this will be the time is there, so commutation will be reliable commutation. This commutation component does not carry any load current, simply it makes use to turn off the main thyristor. Both class A and class B turn off is self commutation type only, so automatically the instant will reach as a 0 point. And now you can see the design component. So means L and C we have to design. So the equation LC, because there is an inductor and then capacitor, once thyristor is on, this is our equivalent. No? There is a thyristor. So thyristor is on, it is in parallel with the L and C. So therefore you write the voltage equation. Once if you write the voltage equation, L and C, that is equal to 0. From that I want I. So we can see that it is a second order system, S square L plus 1 by C into I of S is equal to 0. From this I of S and then inverse Laplace, then from that I of T. So you can write that I of T, EdC into of T by L into sin omega naught T. This is the current path to the circuit. So omega naught is equal to root of 1 by LC. And now here there is a peak commutating current, so that is ICP. This is expressed IC, that is equal to, I can write ICP into omega naught. This is the expression if we derive. And what is ICP? It is a peak capacitance current. So what is the peak capacitance? VDC into root C by L. That we can represent as a peak capacitance current, or in this point we can say that commutating current. That so peak discharge current of the capacitor is assumed to be twice that of the load current. So just for complete commutation, we make use of that sentence. So peak capacitance current must be twice that of the load current, and then SCR is reverse bias is approximately equal to 1/4 of the period. So that's the formula. You can see that peak capacitance current, that is equal to twice of the load current, that is equal to VDC into root C by L. Another one, turn off time is equal to quarter waves, that is pi by 2 root of LC. So that is your parameters turn off time. You can easily calculate once if you know L and C values, we can get it what is the turn off time of a device. Now we'll see that class C commutation, or also called as a complementary commutation. What is the meaning of this complementary commutation? Here there is no specific main thyristor and auxiliary or something else. Both thyristors are there in our circuit. If any instant I want to turn on this T1, and after some instant you want to turn off this, you make use of T2. If you turn on T2, T1 will be off, or T2 is on, you turn on T1, then T2 will be off, like this. That is a complementary commutation. Now we'll see that steps also. So it is very simple. Waveform may be little bit repeated waveform I used, so that's why it will be lengthy, but you just consider only one instant. Up to this is sufficient. First instant is this one, or you can say that this is the first instant. So for that, what I have to do is, first I have to give the firing pulse to the thyristor 1. So I am giving pulse to the thyristor, and as per you can see that IG1, I am giving pulse to the thyristor. Then what will happen? Anybody try to analyze, forget about the waveform, see the circuit. Once if you understand the circuit waveform, you can draw by your own. I am giving pulse, fine. And now once the thyristor is turned on, what will happen? Again two currents. You can see one current will pass like this. This is the current. You can see that current is passing through the T1. It starts plus, go to R1, then T1 to PS. So then what is the value of current? IR1, current passed through the resistor, that is resistor 1, Vs by R1. Initially, voltage or zero mode of operation, you can see that thyristor 1 is off, 2 is off, voltage across the capacitor is 0. That is the mode 0. Now we start mode 1. What is mode 1? Giving pulse to the thyristor. Then two currents will pass. One current is like this. Other current you can see. This goes to the R2 and goes to the capacitor. Then it goes to the T1. See, all of you try to see the current directions. Anyhow, I will show once again. It will pass one current, that is a T1 current, and another current also is there to pass R2, and it goes to the C, and then like this. Then what will happen? You can see current is passing through T1, then another current is passing through the capacitor. So the two currents pass through this thyristor. Then what is this total current pass through the thyristor now? IT1 is equal to Vs by R1 plus Vs by R2. Initially, voltage across the capacitor is 0. That's why maximum current pass through the capacitor. What is that maximum? Vs by R2. Initially, after that, after some instant, what will happen? Capacitor try to charge. While it is charging this, then the current pass through this is going to be reduced. So once it is going to be reduced, then this current will be gradually reduced. Finally, after some time, the voltage across the capacitor is reaches to the maximum, means Vs. Then the no current pass through the capacitor. Then this term will be vanish. Only one current will pass Vs by R1. So that is the initial understanding. You can see that. Now I am giving firing pulse to the SCR1. Then the initial current will be high. What is that value? Vs by or Vs into 1 by R1 plus 1 by R2. Then later on, while it is charging the capacitor, current passed through that capacitor will be decreases. Once it is charged completely, current passed through the capacitor is 0. Then it is gradually Vs by R2 will be decreases. Finally, one point of time, the capacitor current will be 0. Then what will happen? You can see that this point I can say that only Vs by R1 only. And what about Vt1? We turn on the device, therefore Vt1 will be 0. This will be remains 0. And what about Vt2? Vt2 we can see that this one is off state, no? Whatever this capacitor voltage, that will be appear across Vt2, because this is on, no? This is on, then the capacitor voltage directly appear across the Vt2. So that's the reason initially that voltage will be 0 and gradually it is charging. So that's why we are showing gradually charging. Once this point reaches, then it is charges completely Vs. Vs is completely reached, no current pass through that. That means Vs by R2 will be 0. It will be there only Vs by R1. Up to now is okay. Now capacitor voltage same as this of the Vt2 only. I made it like this, exactly same as that, initially 0 and gradually rising. It is reaches to the Vs and will maintain Vs as such until unless if there is a path for discharging. So that will be same as that point. And now what is IT2? Why I made it 0? IT2 means that thyristor is not turn on. Thyristor is not turn on. That's why current pass through the thyristor 2 will be 0. And what is the IC? Capacitor current. So initially voltage is 0. That's why capacitor current is maximum. And gradually voltage is developed and current will be 0. Once this point reaches at t is equal to t1, it is reaches to the 0 current. That means it is already reaches to the Vs. All the instant the voltage across the capacitor is Vs. That's all. That is the first mode of operation. Now up to this is fine. If you have any doubt, you can ask me. Initially I am firing the device. Then total current is sum of these two currents. One is the T1 current, another one is the capacitor current. So after that capacitor is gradually charging. Once it reaches complete charge, no current will allow and it will maintain only Vs by R1. And the thyristor is on 0. And the thyristor 2 voltage same as the capacitor voltage. So that's why these two waveforms are same at this instant. And then IT2 is off state, current is 0. And IC means whatever capacitor current. So this is the one mode of operation. Now the question is, whenever I want to turn off the T1, you fire the what? Thyristor 2. If I fire the thyristor 2, then what will happen? You can see that I am conducting this. So once the thyristor 2 is on, then what is the condition now? Minus is, you can see that this point, if I fire the thyristor T2, minus plate is directly connected to anode of thyristor 1 and plus plate is connected through T2, it is connected to cathode. See this direction. Minus plate is directly connected to anode. Minus plate is connected to anode and plus plate is connected to cathode. So what is the voltage across the thyristor 1 now? It's a reverse voltage applied across the thyristor 1. So therefore thyristor 1 immediately turn off. If thyristor 1 is turned off, then what is the charging? It goes to like this to T2. That's why T1 I made it as off, and now T2 is on. That's why I made it 0. And this voltage, because the charging path is now is this direction instead of this magnitude. Earlier this side is plus, this one is minus. No, now plus is entering into this minus side, then the polarities is going to be change over. So that means charge in the positive direction. So or with respect to second plate, if you consider, that is a earlier it is a positive, now it change over to the negative. Now because current is entering in this direction, earlier entering into this direction it is a positive, now entering into opposite direction it is a negative. So now it is changeover taking place after some time. If you want, you can make it as at T2 point, it is changeover from plus Vs to minus Vs. Then automatically current pass through the thyristor 2 also will be two currents. So initially this Vs and Vs2 Vs and another, this is going to be to R2, and that current is initial, and later on one of the current will make it as a 0, that is Vs by R1, that will be 0 and it remains in the Vs by R2. And this is also capacitor current changeover is taking place, and that will be remain 0 once if it changes to the minus Vs. So that is the mode 2 operation. Now it will become as a original position and repeat that cycle. So with this only small steps, again we have to fire the T2. Now if T2 is conducting, again I want to turn off the T2, you fire the T1. Then if you fire the T1, what will happen? The polarities will reverse. No, this is plus and this one is minus. And minus is connected to the anode and plus is connected to cathode, and this is going to be turn off. That's all. So like that cycle is going to be repeated. Same thing I mentioned here. See this, initially thyristor T1 is on, there is a two currents will pass through that. One current is load current, another current you can see that capacitor current, the blue one. So it is going to be thyristor only. And later on, that's what I already mentioned, all these things, Vs by R1, Vs by R2, and total current is sum of that. And initially voltage across the capacitor is 0, and I calculated the total current. All whatever I explained so far, I mentioned here also for your quick reference. And now we can see that once the current is passing through this, the two currents is initially, then later on whenever you want to turn off the T1, you fire the T2. So that I will show. This is the first mode of operation, whatever I explained so far. And now if I fire the T2, then the thyristor T1 will be off and current is passing through. You can see that load, capacitor, and then thyristor T2. And similarly, there is other current, is a load current of thyristor T2. It goes to source, then R2, and then T2, it goes to source. So there is again two currents, and again that scenario, what will happen, that source currents and all, you can represent that. And now after that, what will happen, polarities is going to be reversed. So once polarities are reversed, what will happen, you can see that this is a plus and this one is a minus. The polarities are reversed. Now the thyristor T1 is ready to conduct. So upper plate, this side is anode side is positive and cathode side is a negative. So therefore it is ready. And when I have to turn on T1, whenever I want to turn off the T2, then you fire the thyristor T1 like this. If you give the pulse T1, then the minus is connected here, plus is connected here, T2 is going to be turn off. That is the complete operation. So given the total circuit operation, and here also commutating elements you have to connect. That's what I given this theory part again. The commutated is connected in series with the load commutating element, and additional thyristor is called complementary thyristor in parallel with the main thyristor, and 0 operation, all T1, T2 is off state and voltage across the capacitor is 0, and that's what the 0 mode of operation. And first mode of operation, you fire the thyristor T1, same whatever I explained so far. So I given the theory version also. Now I am firing the T1, then what will happen? Two currents. So one is the load current, another one is the commutating current or a capacitor current, and after that there is a path of load current I mentioned, then commutating current also I mentioned, and after that capacitor will get charged in the supply voltage VDC, then it won't allow any current pass through that. So then what is the status? T2 is off, voltage across it is reaches to the VDC, and the T1 is on state. Now mode 2 operation, give the firing pulse to the T2 and T2 will on. Once T2 is on, then what will happen? Negative plate is of the capacitor is connected to anode of T1, positive plate is connected to the cathode of T1. So then T1 is going to be turned off. So once T1 is turned off, because reverse voltage applied across that, the C is going to be take place through the load, it is charged in the other polarities. Again, this is the charging path. And after that, again what will happen? Mode 2 starts and device of T2 is on state and voltage across that is already changed that polarity, and after some time again T1 is going to trigger and cycle is going to be repeated. So this is the circuit operation, very small steps. So you just remember, open the circuit and see that steps. And now what will happen? I want to, this will be used under Bedford inverter, that is McMurray Bedford inverter. This is one of the inverter types like series parallel inverter. That is a commutation circuit is required. That's why in McMurray Bedford inverter complementary commutation is required. And now this will be used up to 1 kilohertz of frequency operation. We can use this. And design consideration, you can see that what is the C. Only we used here as a capacitor. Now we have to design the capacitor C. That means C is charged to VDC through R2. Then we will write the voltage equation, and that will be I is equal to VDC by R1 into e power minus T by RC. That R means R1. And now therefore voltage across thyristor T1, I can write VT1 is nothing but, see that circuit is like this, no? Source, and here we can make it as a T1, load resistor, then T1. Now I want to measure voltage across the T1 here. Then what is that? This is a VDC and minus this drop because T1 is there, no? So that will become as a VT1. That's all. VDC minus I into R will give as a VT1. So in that VDC, I into R, R1 here in the case, and we'll get it as a this VT1 is. What is the, you can see the T1 is going to be turned off, and hence EC. So this voltage is same as this voltage, and we'll get it as a VC is equal to VDC, T is equal to turn off. Capacitor voltage will be the 0, reverse voltage applied. So from that we'll get it as 0 is equal to 1 minus 2 into e power minus T off by R1C. From this T off we can get it, and this is the formula for T off. R I want is C. So therefore C is equal to what I can write? T off by turn off time of thyristor is given in the problem and divided by 0.6931 into R1. That is a, see if you want 1 by 0.691 also you can calculate that. I think 1.44 into T off by R1 into C. So that way also you can find what is the value of C. That's what 1.44 T off by R1. C is equal to that one. So that is the formula we can use it. This is the problem in class C commutation. Vs is given, R1 is given, R2 is given. Peak value of current T1, T2. Capacitor they ask that turn off time is 40 microseconds. Safety factor is 2. So that safety factor is wherever T off is there, we must use the circuit turn off time T off plus delta T. Normal formula will be, means some time we have to given. So safety factor is given 2, so you just take it as a 2 times of that. So we must use that safety factor is 2. So now point there is a value is given. Now directly C value we can calculate it. C is equal to what? 1.44 into T off by R1. So direct formula. So now they are asked as a peak value of currents of T1 as well as T2. As you know that formula Vs 1 by R1 plus 2 by R2, that will be as a peak of thyristor T1, and this is a thyristor T2. We get it as a current here, and apart from that C value, that is equal to, because based on the formula we can get it as a C is equal to this formula, or directly you can use ln 2 value also 1.44 into Tc by R1, direct formula you can use it, and the Tc is nothing but a turn off time plus delta T, and safety factor is given to 2 times of turn off time we can give it. So 2 into 40 microsecond by R1 value is a 10 ln 2. So R you can use here as a 1.44 directly instead of using this. So that will give as a capacitor. This much value of capacitor you have to use there for the reliable operation. So that is a 1.54 microfarads. So choose the capacitor larger size just before you can make use of this 11.54 you have to use it. And another one you can see that circuit turn off time. For the given data, what is the TC we have to use it. So 0.693 into RC, R is given, C is given, we will get it as a 26 microsecond is a turn off time. Similarly, class D commutation. What is the class D commutation? It is auxiliary commutation. So make use of this auxiliary thyristor. We are going to turn off the main thyristor. So that's why we call it as a this is a auxiliary commutation. Now we can see initially I have to charge the capacitor. To charge this capacitor, we have to fire the main auxiliary thyristor. So if I fire, this is upper plate is plus, just correct it. Upper plate is plus, lower plate is minus initially. To charge the capacitor, thyristor or TA will be on. If TA is on, what will happen, anybody? Current will pass like this. That's all. So current is passing like this. Then once the capacitor is completely charged, no current pass through the capacitor. Therefore automatically TA is going to be turned off. So that is the mode 0 operation. Carefully understand step by step. Supply is given to the thyristor, and then supply is given to the circuit and give the firing pulse to the auxiliary thyristor. Auxiliary thyristor will on. Once auxiliary is on, current will pass through the capacitor. The capacitor will charge us to the same as the source voltage. Once it is completely charged, no current pass through the thyristor, and thyristor TA will be turned off automatically. Over. That is the mode 0. And mode 1 operation, what I want to do, you fire the main thyristor. If I fire the main thyristor, there is a 2 currents. One is directly load current. This is a load current. Another current is, I told no, upper is plus, just correct it. This is a plus and this is minus initially. And plus is passes through the T1 and goes to the R and diode to the minus. So 2 current pass through this capacitor, main thyristor. And now total current is what? Load current plus commutating current, because it is a resonant loop. And now it is completely discharged, means polarity will reverse, minus and plus. That is mode 1 operation over. Just give the firing pulse to the T1 and it will pass the 2 current. One current is T1, mean load current. Another current is a commutating current, like this. So therefore sum will be the total current. And now once the polarities are reversed, that is the purpose I used as a diode. It won't allow to discharge in the opposite direction, because this will prevent the negative discharge. Now what will happen? Upper plate is minus, lower plate is plus. So now like this you can see the mode 1 load current is constant, capacitor current gradually rises and then decreases to 0, and total current of thyristor is sum of these two currents. Once the capacitor is completely charged, it won't allow any current pass through that. That's why only the load current will pass through the thyristor. So this is the, and then initially voltage will be Vs, no, because it is charged in mode 0 operation. Now it is change over from Vs to minus Vs because polarities are reversed. So this is voltage across thyristor is 0 because it is on. That is the mode 1 operation. And mode 2 operation, to turn off main thyristor, I turn on the auxiliary thyristor. Now this is minus, this is plus, auxiliary thyristor is on. What will happen? Plus is connected to the cathode, minus is connected to anode. Now the current is passing opposite direction. Load current is like this and commutating current is opposite. Whenever the capacitor current is more than the load current, this main thyristor is going to be turn off. That's all. Very simple logic. You see that 3 steps. Remember, initially this is plus and this is minus. Initially, what will happen? Fire the auxiliary thyristor to turn on this one, and then capacitor will charge. Automatically auxiliary thyristor will be turned off. Then fire the main thyristor. 2 current will pass. One current is capacitor current, other current is load current. After some time, polarities will reverse. Then fire the auxiliary thyristor, and capacitor current is pass opposite direction of main thyristor. Whenever the current, capacitor current is more than the load current, thyristor T1 will be turned off over. So like that. But I mentioned the like this. If you see these slides, you can easily understand the same thing. Current is passing through auxiliary to charge the capacitor. The next step, I am firing the main thyristor. Then what will happen? 2 currents. One is this current, another one is this loop current, the resonance loop. Then polarities will reverse. Then what will happen? Again, it is charging through this. Load will supply the capacitor. Now we can see this. Whenever if you fire the auxiliary current, this current will opposite and this will be turned off, and then the current is passing through the load, it will charge the polarities. Now it will become operation, power is minus as usual of operation, and it will give the fire impulse to the T1. That's all. So now we can see that that's the part only I mentioned here. And design part you can see that it will be as a yeah. So you can see this design part, commutating current. So the capacitor voltage minus VDQ to 0 to turn off the thyristor. So remains in the constant to turn off. So Q is equal to CV formula. You can make it as a C is equal to, see that Q is equal to CV. So from that C is equal to Q by V. What is Q? I into T. So that T is T of I is a load current. So that will get it as directly C value. And another value what we want is L value. So for that L value, peak capacitance current is known to you, VDC into root by L by C. And from that L is equal to. So you can see that there is a statement, peak capacitance current is always less than the maximum load current. So this is the condition. From that maximum load current is, you can consider from that requirement, and the peak capacitance current VDC into root C by L. From that L is equal to. So this is the L formula. So using this, we can design our L value and C value. So now we'll see that another class in the next class. I think time over. If I have any doubt, you ask me. Otherwise, you can leave now.